All right, greetings everyone. Welcome to the second part of the video now on adding and subtracting rational expressions. And I know as I talk, none of you will be giving me this look through your computer screens that the little girl has in this GIF, but maybe you know other people that would think this way. Okay, so we're going to start with first of all, some kind of general tips for this next phase of adding and subtracting rational expressions, because we're going to look at how we get common denominators. So here's how that works. First, if we can, we're going to factor the denominators, including it might be helpful to find prime factorizations of any numerical factors. You don't necessarily have to do that part, but it might be helpful. Then here's the key, is that the least common denominator will include all of the distinct factors. So if you've studied things like unions and intersections, kind of what this is saying is that the common denominator will be the union of all the distinct factors. But basically, a more simple way to say that is that anything that's in any of the denominators, unless it's repeated, needs to be in both denominators. And we'll look at some more concrete examples of that. And then we multiply the numerator and denominator by the missing factors, just like we do when we add fractions with numbers. So what will this look like? Well, we're going to start first of all by just finding some common denominators and rewriting our terms based on those. So we'll look at the first one. We have the 3 over 4x and x over 6. Notice first of all the denominators are not the same, right? So this means we need to get a common denominator. Now in this case, luckily both are just single expressions or single terms. So finding the common denominator can be a little more straightforward. So first of all, we'll look at the numbers. So we have a 4 and a 6. And want to think about what is the least common multiple or least common denominator between those two. We actually saw in a previous example that in this case it would be 12. So therefore we know that the denominators of both of these will contain 12 for a common denominator. And then we're going to look at the variables. So here this one contains an x and this one does not. And as you recall from that previous slide, again, we want the common denominator to contain all the different factors that appear in any of the denominators. So since there's an x in the first denominator, it would need to still be in the first denominator, but we need to include one in the second denominator. Okay, so we look here, we find that our common denominator here would be 12x. All right, so now that we've got that, then we figure out how to change the terms based on the common denominator. So we think about to go from 4x to 12x. What did we have to multiply by to get that? Well, the answer is 3. 3 times 4x would give us 12x. So we do the same thing with the numerator. So we have a numerator of 3. We're going to multiply that by 3. And our new numerator would now be 9. For the second term, okay, to go from 6 to 12x, well, in that case, we not only had to multiply by 2 to get the 12, but we also had to multiply an x by an x, okay, to make it 12x. So then we have to do the same thing with the numerator. So this x here, we're going to multiply by 2x. So x times 2x will give us 2x squared as our new denominator, or excuse me, numerator. So now we have our new terms with common denominators would be 9 over 12x and 2x squared over 12x. And we could use those to add or subtract as needed. Okay. All right, let's look at the second one then. Again, we notice the denominators are not the same in this case. And also in this case, they are more than just a single term, right? We have some what we call binomials, since there are 2 terms in each. And so again, following the instructions from the previous slide, we want to start by seeing if we can factor either of these. And first of all, I want to look at this 3t plus 3. I notice that can factor because both terms have a 3 in common, so I can factor out a 3, which would give me a t plus 1 left over. So that first term becomes a 4 over 3 times t plus 1. The second one, this denominator here, the t plus 1, that won't factor. So we'll just leave it as t over t plus 1. And now we have to determine our common denominator. So again, we're going to look at the two sets of denominators, look at what they have in common, what they have its difference. We want to make sure we include any and all factors that appear. So first of all, we notice that both of them contain a t plus 1. So that's going to need to be in our denominator, common denominator. And then we also notice that the first one contains a 3 and the second one does not. So therefore we know that our common denominator should also contain a 3. Okay, so this is what we're looking at here. So our common denominator in this case ends up being 3 times t plus 1. All right, then we go to change our numerators. And first of all, we notice for the first term, the first expression, right, the denominator did not actually change, right? It stayed as 3 times t plus 1. So what that tells us then is the numerator also does not need to change. And so that will just become, or stay 4. For the second term, oh boy. Hold on, we're fine. There we go. So I don't know if you guys could see that or not, but my screen just went a little wonky. We noticed that the original denominator was just t plus 1, and now it's become 3 times t plus 1, which means we've multiplied by 3. And so we have to do the same thing with the numerator. So we'll take that t, multiply it by 3, and we get that our new numerator is 3t. Okay, so our expressions have now become 4 over 3t plus 1 and 3t over 3 times t plus 1, which I maybe said something wrong the first time. All right, so we've got both of these pairs with common denominators. This is helpful for us now because we can now do some algebra. So, for example, if we're going to do 3 over 4x plus x over 6, those are being added. So we know we would need to get a common denominator, which we already did. So that first term becomes 9 over 12x, plus the second term becomes 2x squared over 12x, as we found on the previous slide. And then, as we know, because we're adding with common denominators, we can just add our numerators. And so this would become 9 plus 2x squared over 12x. And in this case, unlike the ones we saw in the previous video, we can't factor the numerator at all, or the denominator, so this would be our final answer. All right. Cool. For the second one here, we have 4 over 3t plus 3 minus t over t plus 1. Again, we've already found what these look like with common denominators. So the first one is 4 over 3 times t plus 1. It did not change. Minus. Second one became 3t over 3 times t plus 1. Again, because we have the common denominators now, we can just subtract our numerators. And in this case, our second numerator is just a single expression, so we don't have to worry about using parentheses. But if it were more than one expression, we would. So the numerator here will become 4 minus 3t, because those aren't like terms, so we can't subtract them anymore. We have 3 times t plus 1. And then just like the previous one, the numerator will not factor, so we'll just leave it as that. And so that'll be our final answer, 4 minus 3t over 3 times t plus 1. Okay. All right, that's it for now. We have one more type of example that'll be coming up on the next video. Thanks for watching.